Hello everyone, we are group number 15 Tunnel Tech Designers. Our design topic is Design the Tunnel Supports based on the Rock Mass Rating, RMR, classification for the shallow tunnel. Let's move on to the content of those presentation. These are the major points we discuss these slides. In this slide shows the names of the supervisors and details of the group members. These are the objectives of our design project we have used. We have used several softwares to achieve these tasks: Excel, Google Earth, Stratter 5, Surfer, AutoCAD, Civil 3D Rock Science softwares. The beginning of subsurface geology of the tunnel. We have defined a hypothetical tunnel geology to construct 6-meter finishing diameter tunnel. As shown, we used 11 borehole data to create the hypothetical geology. This is the longitudinal section of the defined tunnel geology, as in the given figure, which shows 5 different rock types the tunnel must go through. These are the 3 projections of the defined geology with corresponding elevations. Now we moved to the detailed drawings of the tunnel geology. These 6 drawings showing all the important geological data, which will be used in further steps. At the end of the defining and analyzing subsurface geology process, we got all the rock properties which will be used in RMR classification. And slide number 16 shows support class classification according to RMR values, and all the support elements shown in below. Rock bolts. First, we look into rock bolts. We used grouted rock bolts for first 4 classes. And for 5th class, we used self-drilling bolts due to unstable ground conditions. This table shows all the lengths and spacings of the rock bolts. Shotcrete. In order to find the shotcrete thicknesses, we used membrane resistance method, which used in civil engineering applications. The table shows shotcrete thicknesses used in corresponding support classes. Due to absence of tectonic activators and seismic vibratrons, we can reduce above thicknesses for class 4 and 5. We have taken average values of thicknesses given by above theory and thicknesses given by Bienwski's guidelines for rock supports. Wire mesh. For our design, we recommended chain link mesh due to higher load capacity and greater deformation capability. These types of wire meshes are cost-effective too. When we use traditional welded meshes, there may be failures can happen. Therefore, additional costs would be added. As labor and material charges, we can avoid these situations with chain meshes. Steel sets. When it comes to steel sets, it's an essential component for unstable ground conditions. We used for 3 bar lattice girders as the steel sets for support class. 5 when RMR value decreases, vertical pressure exerted on steel sets increases. Therefore, spacing between steel sets changing with RMR values. For support class 5, we have designed double wire mesh connected to the lattice girder above and below. Lattice girders provides higher strength and better performance than traditional steel sets. In tunneling, the below table shows dimensions of the lattice 3-bar lattice girder. Now we can observe how the spacing of the lattice girders changing with RMR values. And also the triangular lattice girder structure distributes loads efficiently and reducing stress concentrations. Next, we can see few disadvantages of selecting lattice girder over other traditional steel sets. We use self-drilling spiles to avoid drill hole collapses. In here, we have chosen span lengths and overlap lengths to keep a simply supported beam better safety. And also, we recommend to use configuration for 50 millimeters of thickness of show turret to avoid face collapse in tunnel face. Eventually, we reached to our design's outputs, which are 5 supports elements, combinations for different ground conditions. Thank you.